Hi, it's David with Oklahoma Ham Radio, the YouTube channel. I want to welcome you back. This is the second in a series of building a magnetic loop antenna that is controlled remotely. As I mentioned in the last video, I moved to a new location, and that location has very strict HOA rules, which I'm fine with. Coming from the last location I was at, I can kind of appreciate some of them. However, one of those HOA rules is you can't have any antennas on your house at all or in your yard, so on and so forth. So with that, building the magnetic loop antenna, I've done a lot more research over the past couple weeks, and I want to share that with you and let you know the path that I'm going down. I went searching to see what other people had done in this regard and found some pretty interesting information that I want to share with you. So if you don't mind, click that like and subscribe and bell and all that if you're interested in this series, so you know when new videos come out. So some of the research that I've done led me to Lofter E. Joe Johnson, I guess. I'm not for sure how to pronounce his name, but he has worked on automating a magnetic loop controller. So let me go ahead and bring this up full screen here. So in this, what he's got is a pretty cool little box that he's built. He's designed it. He's done all the hard work, really. Basically, the gist of it is that you can use an encoder that then drives his board, and that board has a teensy, I think it's a 3.2 controller on it, and some stepper motors, and a serial connector on the back that can be used to connect to motors and drive those motors. It has learning capabilities, and you can basically set locations of that variable capacitor so that when your radio tunes to a certain frequency, passes that information to this controller automatically moves to that location. Another cool feature that he's got is let's say that you've got 20 locations set for different frequencies. What he's able to do is take those locations of that variable capacitor at those different frequencies and estimate where it needs to be moved to for the frequency that you just jumped to. It does work with all of these various radios, but this TS2000 is the one that I'm interested in because I have a radio that communicates using that protocol, and those settings, those variables that are passed, it uses that set of instructions. So that's pretty cool. It also, uses a stepper motor, but he goes through and talks about at length what he did in order to build out his, this controller. He gives schematics for it. He gives what to do on the teensy, in-stop locations, but he also prints out this board that says 3.1. Maybe it's 3.1. I think it's a 3.2. I think that this is an old board design that he had, but he prints out these boards, and if you want one of these boards, you can order it from him. You just email him, and he will ship it to you. He does ship fairly quickly. I'd say very quickly. I got mine 3 or 4 days after I ordered it from him. Seems like a very nice guy. It does talk about using different type of stepper motor controllers and the setup for the different stepper motor controllers. I'm using one of these DRV 8825s. He also has the ability to hook up a SWR meter. Basically, it tells you where to go to purchase those SWR meters and how to modify them to handle much more wattage than what currently they're designed to handle. And in this diagram, or this picture down here, this is the stepper motor, the SWR meter tied in. It seems pretty well thought out. The SWR meter will let your motor fine tune that location, or find that location that it needs to be set to for the frequency that you're on. And then you can use the encoder, this knob right here, to turn to find the best point on that SWR meter, and then actually on your radio, and then you can set that location for that frequency, and then it uses that with the logic that's built in to say, okay, here's another point of information that I have in order to more quickly adjust to a frequency that's around that range. So that's pretty cool. He does have all the firmware, all the menus are well documented. It does have detailed instructions on how to use the device. It does talk about backlash and slop and how to adjust for that. Variable capacitor settings. Here's the code. No, I'm sorry. Here is one chunk of the code that is basically a settings file that you can go in and manually modify. He does have this location on YouTube that shows his controller working, and he's got it broke down into what different time spaces you need to go to within that video in order to see how it works. And then he talks about building his magnetic loop and what he's done with the magnetic loop. But down here at the bottom, he's also got all of the various documents from the history of him going through this project. He's got the right here, the latest, which you can see it's updated January 21st, 2020, so it's fairly current. The latest code that you can flash to your Teensy. He also has a BOM, basically the materials that you would want to buy, which is right here. He's got it all listed out here, where to go to buy the parts, and then specific things like this particular encoder. This is where he gets it from. You could also use other encoders. He talks about that. He talks about the motors and where he got those from. He talks about the SWR modification and what you need to do to modify the SWR meter, schematics, how to modify the Teensy to get rid of the 5 volts in from the USB because that's powered off the board. There's a schematic of the board. If you get the version 3 of the board, which you need to do, which I got version 4 of the board, the assembly instructions with pictures. This talks about the SWR component and how to connect that SWR meter in to be able to be read by the Teensy. Talks about where to get that from, and another option for the SWR meter. There's the back of the controller, what he's doing with different connections on the back of the controller. I mean, it's a very, very good document. Incredibly good document. What he's doing with connecting to the radio, how he's got that set up. A box is at the radio. Here's a cable coming back. Box that's at the antenna, and what's going to the antenna from the radio, how to get all that wired in. So very thorough document, 17 pages of documentation, including where to buy these components from. So I've ordered all of these components, printed out the document, read it multiple times. It seems very good. He even tells you where to get the aluminum box, the housing that he uses, this bezel that goes around the screen. He mentions where he got that bezel, which is right here. Everything at the time of this recording was easy to order. Very few things were on back order. So, in a week I got almost everything that's needed for this particular component of the antenna build. Some more research that I did took me to this page, and he talks at length about a lot of research that he conducted and how he conducted that research and the results that he got from that research. I'll put these links in the description, but this is a very good article. It talks about the voltage and things on a magnetic loop, and the tuning capacitors, what he used, how he did it, what he got ultimately to use, what to look out for on those vacuum variable capacitors. Talks about the coupling loop, different ways to connect that coupling loop, some good things, some bad things, some different things that he attempted and tested out. Talks about what not to do here, how to add in balun, basically a one-to-one balun. Lots of detailed information, different ways of driving the loop, and different results that he got when he drove that loop in different ways. And I'm going to get down here, the different radiation patterns that he got from driving the loop in different ways. Obviously, he put a lot of research in. Building his loop, things he used to build his loop, how he built his loop in depth, a look at what he built, his VNA that he used to do analysis on the loop, and what he saw mounting it vertically versus horizontally, how he did that, so on, how he bent the tubing to be in the circumference that he was looking for, the brackets he uses to connect to his variable capacitor, so on and so on and so on. The results, his backyard, what it looked like, what his results, sunspot activity, how he measured to see what the motor strength needed to be to turn the variable capacitor that he got, and then how he measured to see how much torque his motor could produce, what he's driving it with. Talks about the shafts and what he did here to hook up a gear-driven or belt-driven connector between the stepper motor and his variable capacitor. He discovered that caused some damage, what to look out for there, how he resolved that. He used some various rods, what he used for driving things, the results he got from there, his, so on and so on and so on. All of this in a document form. What he did this is what somebody else did for stop switches, using a 3D printer to build a bracket to use. He ended up going with this motor, Here's the parts that he used here later, and it shows how he set up his stop switches, how he's driving this basically screw, which has this piece on it that hits these stop switches as it rotates, right? So this moves up and down that screw, and it hits these stop switches to prevent him from hitting the ends or the extents of this variable capacitor, potentially damaging it. He used a rod here to isolate electronically these components over here from the variable capacitor. He goes through and shows multiple pictures of all of this, what he got set up. Here you go, this is a stop switch, and showing that this slides up and hits the stop switch. Some various, this is an encoder basically that he's using to count the steps. He's using Cat5 cable or Cat6, I'm not for sure, but to communicate back to his controller box. And he shows putting it all on, how he mounted things, how he waterproofed it, so on and so forth. So very nice document that is very much related to what I'm doing. Here's what he did for his control box. You know, he does it all a little bit differently, but it's still very, very good. It shows his schematic of what he did right here, and then how he's driving the motors here. His little remote control, basically a potentiometer, is what he's using in here to move things. And then it goes into more detail and a lot of various, and this is how he built his rotator. Here's a video, which I'll include that also in the link. So this is what I was thinking about doing for adjusting this loop shape. Same type thing. His has a 4-inch throw instead of a 2-inch throw on that linear actuator. But here's all of the locations that he got information from. So very, very thorough documentation. I also saw a couple YouTube videos that impressed me about how other people had done things, and I'll include some of those in the notes of this video also. So in doing all of that research, I decided to go down the path of, at least for the variable capacitor, using something that somebody else has already designed and not reinventing the wheel, especially since the SWR meter can be built in to that device, and the logic is already built in order to tune automatically to different, based on different frequencies. So my Flex 6400 communicates on that Kenwood 2000 protocol, I think it is, and uses those commands. It has a few other commands also, but there's no need for that. That should allow me to communicate to this box through the computer and be able to get the information as to what frequency I'm at, how many watts I'm running and feeding that antenna with. It also would let me set the wattage to a certain, like 5 watts or whatever, as opposed to trying to tune things with 100 watts initially and things like that. So all of that can be done very easily. I can use that and write some code to on the Mac to be able to transfer those commands via serial connection to the box. So that's the path I'm going down. Just want to give an update on this. Like I said, parts are coming in still, and it's not the parts. Well, let me put it this way. I bought a drill press so that I could work on this project. I've wanted one for a long time anyway. I've bought some bench vise holders, whatever you want to call them, bench vise, to smash ends of things and hold things for me and all that kind of stuff. My 3D printers both didn't really survive the move very well. So I've got a different 3D printer coming in because I just don't want to mess with it. I've had those for 7 years, and believe me, I've put them through their paces. So they're well worn in. I've got a controller board that's messing up on one of them, and the other one I haven't. I tried printing and it just didn't work well. So I may combine those two into one 3D printer. Not for sure yet if I really want to tackle that, but I do have an Ultimaker coming in. I've always wanted an Ultimaker. So anyway, that's where I'm at right now, waiting for copper pipe to come in and things like, tubing and various things like that aren't controller box related, but are essential for a magnetic loop antenna. So it's also, like I said, Mother's Day weekend. So this video is about all I'm going to do for this project this weekend, I think. Anyway, thanks for stopping by. 73, and don't forget to like, subscribe, hit the bell, and that way you know when I get all these parts in and can start building this antenna out. Thanks, guys. Bye.